Okay, so good morning to all of you. I welcome to all Home Education. I, Dr. N. N. Dave, on behalf of Om College of Science and PG Center at Junagadh, welcome you all in this interesting webinar. In this pandemic, as we know, physical education is not possible. So we at Om initiated webinar series on various interesting topics of science. This is our third very important webinar. Let me tell you that we have more than 250 registration from Gujarat and other states. So this is now national level webinar. Today we have a very experienced and prominent speaker, Dr. Malay Bhatt. Uh, Dr. Bhatt did his master's in physical chemistry and he was a university topper in his master's. He pursued his doctorate in medicinal chemistry as well. He published five books and seven research articles in the national and international reputed journals. He also have more than 80 active participation in international, national, and regional level. Of course, he teaches in bachelor's and master students. So he has a total 12 years of experience. He also providing his valuable inputs to various industries as a consultant. He is a lifetime member of Association of Chemists and Biologists. And very important, under his mentorship, his one postgraduate student has filed a patent recently. So we have very versatile speaker, Dr. Malay Bhatt. Uh, the topic is polymer. Polymer is a general topic that will help to all kinds of students, all branch of students, whether he or she is from life sciences, chemistry, microbiology, biotechnology, and other fields. So the topic is polymer, huge field of opportunity. Sir will discuss about opportunities in the field of polymer. Dr. Malay Bhatt is right now assistant professor in Kadi Sarva Vidyalay, which is a deemed university situated at Kadi district, Mehsana. So let's not waste further time, and I'm inviting Dr. Malay Bhatt to start the important topic.
Thank you so much, Dave sir, for your kind words. And let me first of all share my presentation. So as you can see on the screen, I am going to deliver a talk on polymers basically. And of course, it is a field of having a huge opportunity for a chemist, right? Now let us discuss of how this thing could change our life. Okay, so obviously from the ancient civilization it was a stone age. Then after humankind have discovered the bronze, then after it was the era of iron and steel, and then after lastly, that means in the last century we have discovered the plastic. Until then it has become the era of polymer age. Okay, so the term polymer and plastic is sometimes confusing for the general public. Now of course we as economists know the fundamental difference between the polymer and plastic. So plastic is basically a very subtype of polymer, but polymer essentially is a very wide field. So in general, plastic is equal to polymer, but polymer is not equal to plastic, right? And now feel free to capture the screenshot of any slide. If you think this slide is will be useful to you, then without hesitation you have your mobile phone and you can capture screenshot, right? Now I'm not going to discuss the entire classification of the polymer, but here I have demonstrated some of the important polymer. So of course our DNA itself is a polymer. Then from the top left corner of the slide, as you can see, the gloves as well as oxygen mask are highly being used in the corona pandemic. And of course the tumbler, toothbrush is of our daily use. Now the beauty is the very bucket which is labeled as Dulux itself is a polymer, and the paint which comes into that particular bucket is also a emulsion type of polymer, right? And if you need the fundamental textbook definition, then it is already written at the top of the slide. Now I would also like to discuss some of the important terminologies which will be written in the upcoming slide. So you should have the clear cut idea that what is monomer, what is oligomer, what is high polymer, what is telechellic polymer, telechellic oligomer, as well as macromer, right? These are the very fundamental things, and I think most of you have studied this particular thing, but sometimes these things simply evaporated because of this vacation kind of thing. So if your polymer is made up with the one type of monomer unit, then it will be labeled as homopolymer. If your polymer is consist with the two type of monomer, then it should be labeled as copolymer. If it is having a more than two unit, then it should be labeled as terpolymer, and so on. Now in case any of you wondering that how we can prepare any polymer sample at lab scale, so this is the most easy method I have demonstrated over here. It is called as radical polymerization. Of course the PG student have some familiarity with this particular technique. I think in the Saurashtra University as well as the many university across the India are covering this technique as a part of their official syllabus in the UG. Okay, so as the slide suggests, it involves basically three type of mechanism. In the first step, it is the initiation process, and in that step your monomer is being activated by the initiator. Then after there will be a chain propagation step, and lastly there will be a termination step. And these are the examples of the polymer which can be prepared by utilizing this radical polymerization technique. So polystyrene, polyacrylonitrile, polymethyl methylacrylate, as well as polyvinyl acetate are some of the popular example. Mind well, there are many polymers which can be prepared with this technique, but these are the some of the most widely used polymer. Now here is a photo from my own lab. So I was having a discussion with my UG faculty, and it was basically a tea break. So I'm about to have my tea at the laboratory, and we have been discussing on how we can prepare anything like this. So I was telling him that we can basically prepare polymer just like a noodle. So he was first of all amazed, and he thinks that I must be joking. So I immediately called my lab assistants, brought some essential compounds, and put these two beakers into the direct sunlight. Okay, the left side of the white beaker is consist of urea and formaldehyde, and I have added hydrogen peroxide as a photo initiator. And as you can see on the right hand side of the saffron beaker, it is basically a resorcinol glue, which is basically made up with the resorcinol and formaldehyde. And you can also found the grass as evidence that I have prepared this particular polymerization process in the presence of sunlight. So I have simply mix up the chemical, put this two beaker into the open grass area at the garden, and I was having a tea. By the time I have completed my tea, that is around 5 to 7 minutes, I once revisited this place, and as you can see, the beaker were ready. And it is due to this pandemic condition, lab went off after that, and but I took a photograph, and they all were amazed. Okay, so of course this was a green approach. I did not provide any heat. I did not utilize any solvent which are toxic or carcinogenic, right? And similarly, I have simply demonstrated this particular two beakers as a benchmark, or I should say standards only, that if I could prepare this kind of material, then you surely can prepare this type of material, and it will be helpful to you whenever you are going to complete your dissertation phase, or if you want to start your industry, right? See, it has many applications. Urea formaldehyde is basically a adhesive grade polymer, a resorcinol glue. It has its own advantage. It is a UV resisting material, as well as it is having a high hydrophobic nature. That means it can be utilized to coat something which can be which can be utilized as a direct contact with water. Suppose any ship, or cruise, or any navy vessel, right? At that time, in their furniture, this kind of material is useful as a adhesive or as a coating surface. Now, of course, don't just get inspired by this two image. You need to also take care of the stoichiometry, as sometimes most of this chemical reaction is exothermic. So it is very easy to calculate the stoichiometry, and that is why I have demonstrated this example. I won't go into detail in the explanation part because it will consume more time, but you can take a screenshot of this particular example for your convenience and read it out later, right? So by this simple calculation, you can have the stoichiometry calculated, and you can have your polymerization process completed within 5 to 10 minutes. And of course, you need to have the idea of Mn bar as well as Mw bar, that is the number average molecular weight as well as weight average molecular weight. And the dispersity is basically a ratio of Mw by Mn bar, right? And similarly, there is a practical calculation of how you can have the calculation of polydispersity. See, the ideal polydispersity index should be 1, but we know as a chemist it will never become 1, right, due to the limitation of polymerization process and the mechanism itself. But for any industrialization process, we need to calculate the polydispersity ratio, or we need to prepare our polymerization sample in such a way that the ratio of polydispersity should not cross the range of 1.5 to 2. In this particular example, the value comes near close around 4. That means this polymer sample cannot be utilized for any molding purpose, or not utilized for any commercialization production process. Now, other than that, there are some more techniques, okay, which involves cationic and anionic polymerization, means the involvement of uh, carbanion and carbanion. See, the beauty of free radical polymerization is you can start up with the commercial grade material also. Means if you have reagent is 50% pure, or if you have a laboratory scale reagent that is around 70 to 80% purity, then radical polymerization process will do the thing. But in order to complete the ionic polymerization, your starting material should be purified at least up to the AR grade level, or it should be free from any chemical impurity or even oxygen, because it involves redox process and ionic species. Otherwise, there will be a chance of side reaction, as well as retardation factor will be there, right? And that is why purity is important in ionic polymerization process. And this is the example of how we can prepare polymethyl methyl acrylate by utilizing anionic approach. Similarly, there is example of cationic polymerization approach, and trifluoroborane is being used as a catalyst or initiator, and polymers which are prepared by this particular technique are mainly of adhesive category, sealant category, insulating oil and lubricant oils only. There is one more technique which called as condensation. See, I'm discussing this technique because I'm sure that some of you will be going to start some industry or some business by the end of their UG and PG career. Okay, and I'm willing to help those particular candidate, and that is why I'm demonstrating this slide as a motivation that you can basically start this type of thing, right? There is no high-fi chemistry, there is no high-fi uh, reagent or any special instrumentation facility required in order to uh, be expert on this particular chemical reaction. So as the name suggests, condensation process basically involves the removal of H2, alcohol, ketone or acid, right? And as you can see at the bottom of the slide, there is a ester formation and water as a byproduct. If you react the dimethyl terephthalate with the glycol, then methanol or methyl alcohol will come out as a byproduct, and polyethyl terephthalate or the dacron is your product. Similarly, there is one more technique which called as step growth. I'll come to this particular technique later, but let us now try to you know appreciate the concept of adipic acid as well as hexamethyl diamine condensation, and you can prepare this nylon 6s. Uh, Nylon 6 can be prepared with the help of self condensation ring opening polymerization of your caprolactam molecule. Nylon was patented by DuPont, while nylon 6 was patented by BASF company. So here is a graphical representation of step growth polymerization. In the very first step, there will be a bond formation between your two monomer. In the propagation step, there will be a chain expansion or the formation of oligomer, I would say. And in the last step, there will be joining of your oligomers to a higher degree of polymer chain. I have already said PET is the example of step growth polymer. So in many of books you will find this two technique which is called a step growth polymerization as well as addition polymerization. Addition polymerization is like a ethene to polyethylene, means the linear formation of polymer. At there you can achieve maximum number of molecular weight. That means a long chain within a short span. That is the beauty of addition polymerization technique. While in step growth polymerization technique, you will be observing a exponential growth, while your long chain will consume more time. Means you will be able to achieve long chain after a long period of time, as it's a slowest step amongst the all. Now let us discuss some industrialization of highly popular polymers such as Dacron. So it was discovered by Britishers in 1941, patented by Britishers, but it was commercialized by DuPont company in 1950, right? And any acid or base, presence of any acid or base can catalyze the process of formation of PET. That means you can enhance your level of yield. And as you can see in this particular figure, from rope to the sailing boat, you will find the presence of Dacron. It is also being used in duct tape as well as coating material, as well as some cushioning material, foaming agent, packaging plastic, etc., etc. Not only that, it has some unique medical applications also. especially in the cardiovascular valves or artificial heart valves, are made up with the Dacron. Dacron has shown its uh, strong and flexible nature. It is also comparatively chemical inert, and it will not cause any, you know, allergic side effect inside human body. So now let us discuss the story of nylon 66. It was firstly reported in 1934, right? And of course, they have commercialized and prepared a fabric out of it, but at the time, a public was not ready. So the marketing team has came up with this crazy idea at that time. They have showed a kind of a fashion show over there, uh, over 3,000 women, and the models were doing ramp walk by simply wearing those nylon stockings at that time, and suddenly overnight nylon has gained popularity during in the European countries. Now, as a chemist, of course, we are interested in how we can prepare and composite this particular material. See, in most of the textbook, it is written as adipic acid only, but the real condition or the reality is, if you start your chemical reaction with adipic acid and hexamethylene diamine, it will consume more energy, more time, and sometimes if you don't provide sufficient amount of heat and pressure, then you will be observing no polymerization process happening at all inside your you know RBF or reaction flask whatsoever. But if you follow this methodology, then as you can see in the top left part of the slide, your polymer will be formed in the middle of the beaker, because diethylamine is basically prepared in NaOH. It is having a much denser environment as compared to adipic adipoyl chloride in hexane, and that is why you will be observing a sandwich like polymer layer with in the middle of your beaker, right? And if you change the composition, that is basically the overall mole ratio of adipoyl chloride, right? Then you will came up with the different outcome of nylon, such as nylon 48, nylon 49, nylon 411, nylon 6 case, nylon 68, 611, and the list could go on and on, right? But out of that, nylon 6 case has having a maximum mechanical and tensile strength, and that is why it has uh, become more popular as compared to the rest of their counterpart. Now lastly, there is a one more important polymer which is called as Kevlar. Okay, and Stephanie Kolek was the girl who have discovered this polymer, and just like any student, she had dreamed of pursue her career in the medical school, but somehow she ended up with this chemistry thing. She was working at the laboratory in 1965. Um, she was basically changing some mole ratio of their copolymer, and immediately notice out that white cloud-like structure inside the reaction vessel, and that is how they have discovered Kevlar. So her group was basically working on the production of lightweight tire. At that time, hard steel wire were used in order to combine with this natural rubber in order to form the integrity of that particular tire, and steel wire has higher weight, and that is why that tire got higher weight, and it means it has a less fuel efficiency. So in order to boost up the fuel efficiency, they were in the search of new kind of nylon like material, but nylon was already patented, and it has a limited tensile strength as compared to steel wire, so it cannot be utilized. So that is why the Kevlar come up into the role. Now India has already achieved its independence in 1947, and I want all of you to focus on the monomer of this Kevlar. By the 1955, we have already established the university and entire infrastructure in the teaching field. But it is very unfortunate to see that no Indian could have ever done this kind of thing since last 50 to 60 years, right? Of course, I will be sharing some research advancement, recent role of Indians later on, but let us now try to digest what I'm trying to convey over here, that it was a very unfortunate event. And of course, this process is similar to the condensation. We are observing HCl as a byproduct. And see, this is not a very hi-fi compound. It is basically a dichloro derivative of adipic acid only. This is a diphenylamine only, phenylene diamine only, right? And this process is simple condensation. Yet, how mentally retarded at that time people would be, that no one had ever imagined something like this. Okay, so in order to explain the application, let me share some short advertisement which is being published by the DuPont company itself.
When you look down on your home planet from space, it's mind-boggling, just so staggeringly beautiful. Being out in space is really the most foreboding, incredibly hostile environment. We can't go into an environment as challenging as that with any doubts, is my spacesuit going to protect me today? Without the presence of Kevlar, I think it would be terrifying.
From 34 million miles above us to several miles below us, and every point in between, you're going to find DuPont Kevlar. Kevlar is pushing the limits on lightweight, fuel-efficient planes. Kevlar helps us explore the frontiers of our capabilities. Kevlar allows us to do these things that haven't been possible before.
Mas isso salvou minha vida. Salvou minha vida.
We provide the first responders with the capability so they can bring people home. Kevlar has been around for a long time, and you still see it in cutting-edge technologies.
We can actually design properties into the material and create something new which doesn't exist before.
There's also this element of discovery in places that hadn't realized the benefits that Kevlar can bring to them.
La cinta Kevlar lo que busca es durabilidad, resistencia, por ende mayor seguridad hacia las personas. Uno tiene que tener control sobre los riesgos.
There's many applications that could benefit from Kevlar, and it's limitless depending on what the imagination is of the people who have the needs.
Is there life out there? Is one of the most profound human questions.
Kevlar allows us to push our limits, to seek those answers to the questions that we have.
The stuff travels. Travels well.
So as the name suggests, it's a monopoly business of the DuPont company. And see, we as a people of science have a bad habit to never take care of our financials, right? And it is time to change that particular scenario. As a good chemist, in order to as search for a good opportunity, you should have the idea of how the financial terms or how the finance of the company who are doing the business in the branch of polymer is really ongoing. So let us take care of some financial data sheets of various industries which are associated in this polymer business. So of course paint is nothing but a very specific adhesive category of polymer, and this financial sheet is from 1st September 2020, and we all are knowing the fact that it was a year of corona. Many of the industry have shown the kind of some sort of depression in their sales, right? But it was the paint industry who is was still in the growth, and there was no impact or anything that is called as a recession on that particular industry. Similarly, no sign of recession in the adhesive category also. These are the top 5 companies for adhesive business in India, and from the 2016 to 2026 they are basically expecting a steady growth of around 8%. And mind well, these all are standardized data. These are not from my home. I have given you a proper reference at the bottom of each slide so you can verify this data. Similarly, as you can see in the global plastic production company, see the graph is not linear. In fact, it is exponential. So there will be a exponential increase in the demand of the plastic up to around 2028. Means there will be money. See, any increase in the terms of sale means there will be a more terms of revenue generation, means more number of money it will be producing at the end of the financial year, means more profit and more money. The finance is very, very simple. See, this is a graph of tire production company. They are also expecting a exponential increase, even though in the time of corona there is no impact on it. And lastly, there is a molding industry, means a company which intakes raw material in the form of raw plastic or plastic granules, and finished product, their finished product would be like any water tank, plastic based water tank, bucket, tumbler, toothbrush, and so on. So that is the molding industry. And as you can see on the very right column of this particular spreadsheet, right, there are only positive figures, means there is only a growth and only profit. No sign of loss is being observed in molding industry also, right? But each thing has their own limitation, so let us try to see or focus on the other side of that particular coin. I would like to share one more movie clip. Now the name of the movie is called as A Plastic Ocean.
I remember the first time I saw a blue whale.
Oh, look. Wow.
I've followed them since childhood.
What do you think it's from? Is it from a ship?
I could see plastic everywhere. We were in what we thought was a relatively pristine environment. I started to wonder what was happening in oceans elsewhere on the planet. Growing up, my world was the ocean. It's where I feel the most spiritual.
As a freediver, it was the place where I proved myself to myself. Finally, have the opportunity to pay the sea back.
Only a fraction of the plastic that we produce is recycled.
This is never going to degrade. It's got nowhere to go.
This was something that these animals, they were forced to endure because it was man-made and we'd put it into their environment.
The record is 276 pieces of plastic inside of one 90-day-old chick.
If the plastics are in the food chain for the dolphin, they're also in our food chain. Exactly.
Communities are built on these landfill sites.
So sweet potatoes, corn, sugarcane, all growing on 40 years of garbage.
Do you have anything not wrapped in plastic?
No.
We have to make our life better for our kids' children.
Change is possible. It starts with us.
So these are the guys who was basically working in the marine biology. They were chasing this blue whale in the Indian Ocean near Sri Lanka, and immediately they have found out the presence of plastic in that particular sea. So they have tried to collect a sample across the globe, and they have came up with this very disappointing conclusion that the plastic is being in the suspended phase in the entire ocean, right? So we have already polluted the entire ocean, right? We have already polluted sea, now the entire ocean. And if you think that is the limit, then I have one worse news for you. See, this research article was been published on December 23 last year. Cyborg baby means any artificial material or implant inside a human body, it is called as a cyborg. Suppose you have any, bone implant or metallic plate in your bone, then it will be called as cyborg. So baby which is not born till today is being affected or polluted with the plastic, right? And if you think I am exaggerating the situation, then here is a proof. This is a screenshot of the research paper. They have called it as a plasticenta. Now the technical term is called as placenta. So placenta is basically a living wire which communicates food, fillings, chemical signal between a mother and a unborn child. But they have found the presence of plastic, and that is why they have labeled it as a plasticenta. Now the study was done in the Italy, so you can imagine the possible worst situation in the country like India and Africa and so on. And they have also provided the proof, right? Of course, this is a graphical representation. You can read it out the entire research paper if you want from any library. Okay. See, they have found the microplastic present in the blood sample of an unborn child, right? And if you think that plastic is inert, then think twice, because I can give you the endless amount of list of toxicity of the plastic material, right? See, PVC is one of the most commercially used plastic, and as you can see on the top right corner, it is having a adverse effect from chronic bronchitis to ulcer and cancer and so on. Similarly, phthalates, which is most commonly found in any soft toys, any Chinese toys for the boys and girls, right? It could basically make them impotent. It could reduce their sperm count. It could, adversely affect on their hormonic cycle. It could act as a retardus to their immune system, and the list is endless, right? Polycarbonate is made up with the bisphenol A kind of substance, which is highly toxic, and it has a maximum carcinogenic property, and it is mostly used as inside any commercial Bisleri water bottle or any purified water. Similarly, polystyrene has their adverse effect. A polyethylene has also have their adverse effect, and the list could be the endless. But this three slide I have specifically utilized over here in order to open the eye and give you the sufficient vision that this type of urea formaldehyde, I have just praised the synthetic procedure, and because this production process involves less energy and this kind of thing, most of the people are still chasing. Of course, it has some great advantage, but it also has their own limitation in terms of human contact. So you need to utilize this type of material where it should never get in contact with the human, for that sake, right? You can take a screenshot, right? Otherwise it will consume much more time. Now if you are being depressed by this presentation or the video and this side effect of the plastic, then you don't have to be worried, right? We as a chemist has a cure. We will always find a cure, right? And the entire world is looking upon us only, because it is the duty of a particular chemist. Then we need to basically alter the production route. We need to basically modify the type of polymerization process or the very polymer. And let me give you one specific example. See, the answer of every pollution which are being made up with the plastic is biodegradable polymer. So of course, as the name suggests, the polymer should degrade automatically or biologically, right? And here is the example of a biodegradable polymer. So lactic acid is commonly available compound. By the following of oligomerization process, you can end up with the lactide, and lactide can be converted into polylactic acid by any of this polymerization technique. And there are sufficient evidence which are being published by several scientists that this particular polylactic acid or PLA is easily undergoes self degradation. Now the other field of opportunity is the conducting material, and these three guys were won the Nobel Prize in 2000 for designing such a material. So they have designed a polyacetylene substance of the polymer which is having a similar conductivity just like any metallic conductor, and that is why they have awarded the Nobel Prize. If you want to mimic similar technology at your lab scale, then you need to think of this two diagram, right? Your ending material, that is your polymer, should have a low band gap. Low band gap means the distance band gap between HOMO and LUMO should be minimal. So any thermally excited electron can easily go into the LUMO and generate electricity as in the form of outermost electron, and that can be utilized for various purpose. Now if you want to focus on recent advancement, right, then in recent year polymer electrolyte has become popular. So as compared to the conventional battery, how this polymer electrolyte are differ. So suppose you have battery in your vehicle, right? It is the still commercial old age technological battery, and if you don't start or run your vehicle for around 2 to 3 months, then that particular battery will be dead for sure, because your electrolyte is basically reacting in a reverse way, and it is because of that diffusion process entire charging will be evaporated, or I should say it will be consumed on the various chemical phenomena such as diffusion, electric double layer formation and that kind of thing. So polymer electrolyte is having their own advantage. The advantage are already listed over here. If you want to know that what is that particular material, then any polythene oxide, polycarbonate based solid polymer, nitrile based polymer, or even a single lithium ion. See, lithium in its ionic state acting as a inorganic homochain polymer, right? So it is also a polymer, not a metal, right? And it has their application. Nowadays we all are having our smartphone, gadgets such as camera, digital camera I should say, a laptop, or even infotainment system in the car, or electrically charged EV. Tata Nexon is a great example of this polyelectrolyte based batteries, right? Other than that, there is also a streaming device which are becoming popular in this our household, and the entertainment technology inside any large spacecraft or aerocraft I should say, aerocraft is the word, is also consist of this polymer electrolyte. The advantage of polyelectrolyte is it is having a more efficient as compared to standard electrolyte. It has also good weight to charge ratio, and I could go on and on. See, in this particular slide there is a three different configuration of how you can utilize this hi-fi organic material in the form of your electrode, right? So let us try to first of all understand, as a PG student or UG student, you might not be able to digest the entire chemical structure But as you can see, the structure is not very complex. It is very simple structure, and you may replicate this kind of thing at your lab scale also. So that is my entire motto, right? And that is why, I'm demonstrating this slide intentionally to all of you, that at least some of you should inspire and try to replicate this kind of thing at your lab scale, right? Now if you want to design battery for a commercial use, then there are two kind of thing you need to keep in mind. At the left hand side, you need to take care of this theoretical parameters such as electron density, power density, cycle life. And on the right hand side, you need to think of their practicality, such as what is the actual life cycle of that particular battery. Now as you may have seen, the fact that even though you have bought a smartphone of around 1 lakh rupee or 50,000 rupee, even in that case they are only providing the warranty on the battery of around 6 months, and any hardcore user will need to charge the smartphone twice a day, not more than twice a day. So that means 180 days of warranty, and during that time you can hardly charge your battery not more than 180 into 2, that is around 360. So the battery life of your 1 lakh rupee smartphone is not more than 360 cycles. The fact is very very simple. And right now they are designing their phone in such a way that the battery is not replaceable, the phone is not repairable. Means once you have charged your phone around 360 cycle, it will be of no use. Okay, and that is why we are we are seeing increase in the terms of pollution globally. The second term, what we meant by safety is, we have also seen some unfortunate event when battery exploded. It is because of this polycarbonated solvent, or most of the time the solvent or inside the battery of electrolyte, they are utilizing a solvent based electrolyte which are chemically active and which are oxidized at a faster rate, and it is because of that we are observing a heating issue as well as blast effect. So polymer based electrolyte, polymer based gel membrane are the safest alternative. Of course, right now there is no production facility inside the India for that technology, and we need to be dependent on country like Korea and China for that. But if you pursue your career in this direction, I'm sure India will have a brighter future in this department also. Now other than that, it has also a great role in the form of energy storage. And now energy storage has a two aspect. One itself is of course a storage capacity of battery. Um the storage charge capacity could also be increased, other as well as the charging time, I mean the discharging time, could also be uh, enhanced with the help of this newly developed energy material. The second application is for your solar devices. You can extract out more juice out of that solar radiation. Means earlier, if your solar panel is producing 2 kW, with the help of this new technology, your panel will be producing around 5 to 7 kilowatt by covering that same surface area. Okay, and you will be pleased to read this very first name. It is written as Harpal C Rana. He was my fellow junior and a friend. He has done his PhD in from Korea. His entire PhD was funded by Samsung. He is also a Marie Curie fellow, and he is going to do his postdoc in France from this 1st of June. So let me discuss his prestigious work, and I'm specifically sharing his example because if a Gujarati can do it, then we all could do it, right? So as you can see in this particular graphical representation, PVA is basically a polyvinyl alcohol. So they have cross-linked this particular polymer, and they have tried to exchange some ion, right? Partially cross-linked and self cross-linked polymer, and they have end up with this different morphology of this same PVA, that is polyvinyl alcohol. So as you can see in this bottom right figure, the structure is capable enough to hold your ion for a longer period of time. Other than that, it is also providing a specific channel for your cation and anions, and that is how they are basically inducing the overall efficiency of that particular cell, right? Now, a very lucrative example of this beautiful technology is a foldable display, foldable mobile phone, right? So, how we can do it? So, this is the graphical representation on by which you can basically synthesize this kind of material. Of course, it will require and demand not only a good instrumentation laboratory setup, but a skilled chemist, right? Not every UG PG chemist can do it, but once you have expertise in the normal polymerization phase, in the normal polymerization field, then after you can replicate this kind of sophisticated practicals, or I should say, uh, experiment also. So MXN means any metal base carbides or nitrides, right? It is called as amixin nowadays, and you need to do the combination of this carbide nitride in any polymer, and that is how you can bend this particular polymer, as well as you can enhance its optical and electrical property. See, there is a one more example on how we can basically prepare a supercapacitor. Supercapacitor means, of course, we can store higher amount of charge in the same area. So these all are 2D structure. 2D means a paper like thickness. The structure will have a thickness of a paper, right? And this can store any charge. Okay. So on the top right side, you can see the chemical composition of this superconducting 2D structure. Now here is a very interesting research paper, thermoelectric variable. And what do we meant by that? Suppose if you are wearing a shirt and or a t-shirt which could capable enough to produce electricity from your body heat, then it will be of great use. No need to carry any charger or power bank. Simply wear a shirt from your body heat. There will be excited electron inside your fabric, and that electron can be poured out and the external circuit in the form of charge, and you can have enjoy in your cell phone for the entire day. It would be especially helpful, uh, especially if we have a the condition just like any tornado or any unfortunate event like that. So at that time this kind of technology could be helpful. Now another field of great opportunity most of the people talking about is the production of self-healing material. So this is a very basic diagram of how one can prepare this self-healing material. You need to have your polymer matrix, as well as some micro encapsulated uh, healing agent, I should say. So the capsule should be made up with the healing agent. You need to also seal this resin tube with some amount of hardener, and let me give you the example of this technology. See, the chemical composition is already written over here on the top right side of this particular slide. This technology is being utilized by NASA, right? E and B is the healing agent, while Grubbs catalyst is acting as a hardener, right? So the companies such as SpaceX, which owned by Elon Musk, is also utilizing similar technology. NASA is also working on the same technology once they have found out the unfortunate accident of their space shuttle. Now the alternative mechanism of self-healing material involves, a thread-like, or I should say the latex-like approach. See, if your material is damaged, then in first step there will be a voting process, then after there will be a randomization process, and then after your material will be healed. Of course, this particular thing can be reversed with the help of any external potential, electrical potential or thermal potential. These are the example. Once again, I want all of you to look at the chemical composition as well as some involvement of name reactions such as Michael addition. See, this chemical reaction are very very simple. The reactant itself is also very very simple, right? What you need to have is a proper dedication and a stronger determination only, right? So in order to be doubly sure, suppose you want to utilize this technology in a spacecraft, then you need to be doubly sure, right? So at that time you need to also have this capsulated approach as well as the fiber approach, and the combination of both these two approach will yield you a faster healing with the better efficiency. Okay. And in case any of you wondering that how we can prepare this self-healing material, then you can start up with a simple compound like this. See, I have demonstrated the entire chemical reaction for your convenience. This is how you can prepare carboxylated polyurethane. Supramolecular rubber is also very popular for the scientists who are working in this field, right? It has excellent efficiency, healing efficiency. It can also be readily prepared. Now, as you can see in this particular figure, there are many applications, such as application in the battery, sub application in the various space science, and so on. Okay, so in 2013 it was the very first time that this self-healing material was commercialized, and then after this process is still ongoing and there is a huge scope. Mind well, there is no company in India who done commercialization in the field of this self-healing material. See, I was trying to propose a project under SSIP, and at that time no one was able to digest the concept of they think that I'm talking about some kind of toughen plastic. Okay, so that is how that particular project was not approved by the SSIP, but I think right now they have changed their scenario, and right now they are more than happy. See, SSIP is something which is called as student startup innovation program. If you have the good idea, then they will provide you the money and funding. Okay, so I wish all of you to go for that particular program and do your own research. Now there are some more images from this application of self-healing material. These are the some of the popular chemical structure which has a power of healing. See, self-healing is nothing but very fast formation of hydrogen bond inside your any coating media, right? So the faster the bond formation, the more will be the healing power, right? So you need to choose your monomer accordingly, and you can also have publication, patent, commercialization, production, monopoly, whatsoever, and ultimately you can make money out of it. See, here is the beauty of self-healing polymer. As you can see in this particular slide, the entire structure was split up into two parts in the figure 2, we have just joined the particular part. After 24 hour, the healing process is around more than 50% has completed, and after 48 hour you won't be able to see even a slightest crack on it, right? So that is the power of self-healing material, and the material they have used is polyisobutylene only, and you can see the chemical structure. It is very, very primitive, right? No high-five chemistry or high-five material is being involved. Even UG PG student can digest this type of chemistry. And lastly, I know I'm running out of time, but please give me 5 more minutes. So polymer has also their very specific application in the field of medicinal chemistry, or I should say any medicinal field, right? So chitosan is one example. It is basically a natural polymer, and it has many industrial application. Other than that, it is used in the tissue engineering, drug delivery, hydrophobicity kind of material, and so on. Cellulose is also a very popular material which is utilized in tissue engineering, drug delivery, biosensors, right? And it is highly utilized in the formation of hydrogel membrane. Now hydrogel membrane is acting as a drug carrier, right? So drug carrier is something which involves high-fi medicinal science. Suppose you want to target a specific drug on a very part of your body. Suppose if a patient is suffering from lung cancer and you need to supply a drug uh, in the lung area only, because it is having the adverse effect to the other part of body. It cannot be simply swallowed up, because it can cause ulcer inside your body. So at that time this hydrogel could be helpful. It has a smaller degradation lifespan, means it can release your drug slowly, and this slowly released drug will be absorbed by your tumoric cell, and that is how you can see the faster healing as compared to the standard drug delivery approach. So it is called as a drug carrier, drug delivery, and that kind of thing. Now other than that, polycaprolactone is also approved by Food and Drug Ministry, and it is also having a smaller similar degradation time, and it has its excellent efficiency in the drug carrier. Now these are some of the polymer which are found to be medicinally important, and there are some research paper. I know I have just showed you the limitation of the styrene, but there are research papers still available in the market, and scientists are still promoting the styrene. You will find the research paper of 2018 and 19 who claims styrene to be a bio-inert material. What a I don't have a proper word, right? But this is the stupid approach, I would say. Now in case any of you will wondering that what is it, tissue engineering, by the way, of course this is not our primary subject, but I think I have utilized the word more than several times, so you should have the idea of how you can basically produce tissue inside your laboratory. Of course it will demand hi-fi sets of skills, as well as very expensive laboratory setup. So it is not something that we can do in our chemistry lab or biology lab, but you can digest the science behind it, right? So that is all I want to say for the today. Thank you so much for your patience hearing, uh, and thank you so much for the organizer. Thank you so much coordinator Dr. Dave sir. Thank you all.